Welcome to the Object Pool pattern, part of our Creational Patterns module. This pattern is all about efficiency. Instead of creating and destroying expensive objects over and over again, you maintain a pool of them and reuse each one. By the end of this video, you will recognize the pattern in real code bases, understand its participants, and know exactly when to reach for it. Imagine your web server handles 1,000 requests per second, and each request opens a fresh database connection. Opening a TCP socket, authenticating and negotiating a protocol takes real time, often 20 to 50 milliseconds. Multiply that by 1,000 requests, and you have a serious bottleneck. The same pain applies to threads, large byte buffers, or any object whose construction is genuinely expensive. We need a smarter strategy than create, use, destroy. Think of your local library. When you want to read a novel, the library does not print a brand new copy just for you. That would be absurdly expensive. Instead, it keeps a fixed collection on the shelf. You borrow a copy, use it, and return it when you are done, so someone else can borrow the very same book. The object pool pattern applies exactly this idea to software. Create objects once, lend them out, and take them back for the next caller. The object pool pattern has three main participants. The pool is the manager. It owns a collection of pre-created objects, hands one to a client on request, and accepts it back when the client is finished. The pooled object is the expensive resource itself, for example a database connection. The client is any code that needs that resource. The two key operations are acquire, which lends an object out, and release, which returns it. Nothing else is created at request time. Let us walk through this code, top to bottom. Database connection is our expensive pooled object. It has an ID to tell instances apart, an in-use flag the pool uses for tracking, and a reset method that clears per request state before the object goes back on the shelf. Connection pool is the pool participant. Its constructor receives a size and uses array.from to eagerly create exactly that many connections up front. This is where the expensive work happens once. The acquire method scans for a connection whose in-use flag is false, marks it true, and returns it to the caller. If none are free, it throws, which signals back pressure. The release method calls reset on the returned connection, clearing in use, and any other state, then leaves it in the pool array ready to be found by the next acquire call. Finally, the client simply calls acquire, uses the connection, and calls release. It never calls new. Here is the collaboration in plain terms. At startup, the pool constructs its objects once, paying the creation cost upfront. When a client calls acquire, the pool finds an idle object, marks it as in use, and hands it over. The client does its work and calls release. Release is critical. It must fully reset the object state. Think clearing query results, resetting buffers, or closing any sub-resources before making the object available again. Skip that step, and you have state leakage, where one request accidentally sees data from a previous one. The main trade-off is that pooled objects consume memory even when nobody is using them. Reach for the object pool when profiling shows that object creation is a real bottleneck. Database connections, native threads, and large pre-allocated buffers are the textbook cases. You also need a sensible cap on how many can exist concurrently. On the other hand, skip it when construction is trivially fast, because you are adding a layer of complexity for no gain. Also skip it when the runtime already pools for you. Most database client libraries manage their own connection pools internally, so wrapping them in another pool is redundant and error-prone. To summarize, the object pool pattern pays an upfront creation cost once and reuses those objects for the lifetime of your application. Clients borrow with acquire and return with release. They never call new. The single most important implementation discipline is resetting object state on every release, because anything left behind becomes a data leak for the next caller. Use the pattern when creation is genuinely expensive and you have a natural concurrency limit. Skip it when those conditions do not hold.